Sorry, hello. Good afternoon, ladies and gentlemen. Before beginning today's program, I would like to ask for a moment of silence as I go through the acknowledgement of the country, please. I would like to acknowledge the traditional owners of the land on which we gather today, the people of the Kulin Nation, and pay my respects to elders past and present. I would also extend that respect to any Aboriginal and Torres Strait Islander people joining us here today. Thank you all for the silence and welcome to the NextGen AI Conference 2025. Thank you. My name is Tim and I'm your host for today. A quick intro of myself. I used to be a student here at Uni Melbourne, but I'm currently studying at Cambridge in the UK. And it's my absolute honor to be back home in Melbourne this winter, co-hosting the NextGen AI event with the wonderful local communities, including AI Development Group Uni Melbourne Venture Club, MOAI, CA Melbourne, and Cambridge EdTech, which I am representing. Also, a huge thank you to the Melbourne Connect team for supporting us over the last few months. The tremendous help has really helped us in countless ways, and thank you very much. So now today's conference isn't about, a boy named Tim finding his way back home to Melbourne, escaping UK, most importantly, and meeting a bunch of new friends here in Melbourne. It's about something that's far more exciting and important. It's about AI, the future of AI, and the next generation. We are here to discuss where we are heading in this dramatical era of technological change. Our core team believe in the acronym, the value of I to the power of 3. Now, I to the power of 3 is not I cubed or, I, in terms of me, the pronoun. It means something very different. It symbolizes for a multiplied and amplified effect of innovation times integration times implementation, where we believe that we together should be imagining, acting, and connecting. At NextGen AI, our co-hosts and the community want to foster a space for wild imagination, cross-disciplinary collaboration, and immediate actions to transform ideas into tangible solutions. Our journey this year started with last week's hackathon from the 23rd to the 30th of August, where 30 teams innovated on really messy real-world problems. And they've done amazing and unbelievable products which will be shown later into today. Today at the conference here, the ultimate goal is to integrate the voice and the perspectives of different talents, researchers, innovators, industry experts, and entrepreneurs to discuss how ideas and discussions can be implemented for real impact. Now, before I dive into any of the core discussion today, I would like to just please allow me to briefly run through the agenda for you today. So now we are in the opening talk where I'm doing the speech. We'll be hearing from our supporters just lately after me. Followed by that, we'll be hearing from Professor Eduard Hovy to deliver a keynote speech to us. And after that, we'll be having a panel discussion of two groups. The first one is of amazing corporate leaders, and the second one is of the outstanding AI founders. And we'll be jumping to a short break afterwards. After the break, we'll be back for a live demo of very inspiring pitch decks, 6 teams. And at the end of the day, we'll be closing up today with a wonderful showcase of the hackathon products from last week. Now, that's enough from me for now. I'd like to pass on to my co-host, Dr. Daisy Liu from AI Development Group, to introduce the supporters and collaborators of the NextGen AI event. Thank you very much.
Thanks, team, for the opening. Okay, thank you. I want to introduce a little bit about the co-host and also our amazing partners and supporters for this conference happening. First of all, this is an annual conference for AI Development Group. It's a AI PhD student club at Uni Melbourne. We just, not a long history, just Today is the second year. I'm the first president and founder of this team, and this year our president is Yiling. He's very busy to help us with the registration now. And next year our president is gonna be Yan. If anyone want to collaborate with us, you can find Yiling for this year and Yan for next year. This year we have amazing co-hosts to help us to make this happen. It's a really long event from a one-week hackathon, and let the hackathon winners to focusing on improving their products and then move to the conference today. We have like the panel discussion, AI startup pitch, and hackathon demo. For like Melbourne Venture Club, they're gonna take care of the pitch session, a startup pitch for 6 amazing AI startup founders to give us like the presentation. And for ML AI community, it's a big community in Melbourne, combined like over 1,000 AI startup founders. They help us to gather all the participants for the hackathon and also publish the event online. For SIA, it's a young community in Melbourne, gather like young people for lots of different events. SIA helps us to organize all the hackathon, like the agenda or the like the host of the 1 week event. And for EduTech, you already know team, right? He's gonna take care of our panel discussion. And also thanks for Melbourne Connect to support the venue and all the registration part. We also have amazing collaborators to make this happen. You can say like some of them are communities, local communities, some are like students club, all helps us a lot. And we also have amazing like partners to support the hackathon winners prize. You know, like when you want to make people compete, you need to give some awards to push them, right? We also have like the pitch prize sponsors to help us. These are like ACASE and Solomon Digital Hub, all gonna support us for some like accelerator, like coaching sessions or meeting room support. There are also some amazing partners make this conference happen. We have GR Academy and ACASE, Heidi Health, Boson Ventures, Melbourne Yard. And I will also introduce our 2 main sponsors. One is Fabulation and the other is NextGen AI. First, I'm gonna introduce the Simon from Fabulation to give us a short talk about what they are doing now. Thank you, Simon.
Thank you. Seems strange to be here as a sponsor, especially considering we're pitching later on. That gives you an indication of just how fast Fabulation is moving at the moment. We are a, oh, you're putting my slide up. Thank you. We are a blockchain and AI combined platform. And we are working to build a fairer, freer, and faster creative economy. For those of you that want to know a bit more detail about that, I will take you into that during my pitch and will wow you with some wonderful information about what we do. But in this session, what I want to do is just to congratulate all of you on the work that you're doing with AI. We see the impact that AI is having on our lives. Just 12 months ago, I don't think I'd ever used ChatGPT. Now I can't do anything without it. The extent that it's moving into our lives is just incredible. Good luck to all of the things that you're doing. Good luck in your careers in AI, and we, and I'm sure lots of other companies will be supporting you as well. There's one thing that I would say as a creative, so I'm a professional writer. There's one thing I would say, and that is bear in mind who you're solving these problems for. We see at the moment that there are huge issues in the publishing industry with AI companies that are taking things that they do not have the right to use, writers' stories, works, etc., etc. Think about what the world is going to look like in 3 to 4 years' time. Do we want to be in a position where AI is doing all the writing, all the drawing, all the creative stuff for us, and the humans are cleaning the toilets? Because that's not a world that I want to live in. So just think about how AI is going to impact those things, and let's make sure that we do AI for the right reasons. As a supportive technology, it's got some wonderful opportunities for us, but let's get the right ones. Thank you.
Thanks, Simon, for the awesome talk. Let's move to our next supporter, NextGen AI. Let's welcome Andrew to the stage. Thank you.
thank you very much. And on behalf of Nexus MD, we're very proud to be involved in this project and to be able to help shape the future of AI in terms of everyone here that's contributing to the AI transformation. One thing we want to talk about is that Nexus believes very much in healthcare. We've spent the last 10, 15 years going through a digital transformation, but we're not finished yet, because what was built to define the digital transformation is not going to take us into the future, not from a sustainable perspective anyway. Now, one of the things I'd like to just sort of frame is that whenever we talk about healthcare and AI, the industry and government is very quick to label AI as just ambient scribes. And whilst that's a very key part of productivity improvements and opportunities in AI, there's a lot more that can be done. And we strongly believe that the key development and work done by everyone here will be contributing towards that. It's a very complex field, medical and healthcare applications, and you need a very complex network of AI agents to be able to develop and deliver some really tangible improvements as we go through. So this is who the Nexus team are. You're going to meet more of us while we're here. We'll have Fina talking as part of the panel coming up, and our CEO and founder, Mike Xu, is here, as well as Kevin Sang, who's one of the judges in the panel. So we're really excited to be part of this group. And we are a native AI company. It shows it can be done, it can be built. We don't need to rely on the technical debt of all the applications that exist, but we're very proud of being able to bring all these new generative AI agents to the market, and certainly around the opportunities with natural language processing. Why are we doing this and why are we here? At the moment, every year, about $10 trillion US, so about $15 trillion is spent on healthcare per year for 8.5 or 8.25 billion people. Now actually, of that, about half the money is spent in North America for 350 million people. So somewhere along the way, either a lot of money is being wasted on too few people, or a lot of people are not getting access to the healthcare that they need. And part of the United Nations Sustainability Program is to deliver sustainable healthcare to the population in the world. And this is very critical, because we know that if you look at the way the world is so far, there's still a lot of the world has not gone through that digital transformation. If we look in India as an example, everyone in India has a mobile phone, but the majority of Indian hospitals are still working on paper. And that's not unusual, because if you go into a private hospital in Australia, nearly every private hospital in Australia is still using paper for their clinical notes. So how do we switch that off? You can't just switch that off. We have to find ways of being able to move forward. Now, the idea of EMRs and healthcare SaaS applications was very critical, but it's not a future step. And one of the things that we do at Nexus is find ways of building technology that exists with the environments that exist so far, but also ways where if you're not digital, how to bring you into the future. So if we look at a paper chart and a paper note by a physician, there are millions of these sitting in files and archives or printed paper lots in Australia, doing nothing. It's wasted healthcare evidence that can help provide information for a better future. So let's use AI to bring it into a digital capability. Let's read every medical note that's been written and printed out there and bring it into the files so that we can actually have all the historical information that's created the evidence that we've structured all our business off today. So healthcare data, through AI, we can create paper notes into being structured key information notes and information for decision support and the ability to make much better informed decisions around how we cater for all the people around the world when it comes to AI and healthcare. So if you'd like to be with us, we're hiring, we're growing and we're expanding. You'll learn more from Fina today, but if you'd like to learn more, come and see us and have a chat at lunch, at the break I should say, we've just had lunch. But looking forward to the rest of the day, and thank you very much for allowing us to be a sponsor for this event.
Oh, thank you so much for these speeches. And, it's wonderful to hear from you. And one of the commonalities or keywords, similar keywords I kind of extracted from your speeches is, complex problems and changes in today's world. And, today's biggest point of today's discussion is to discuss it from multiple perspectives. And now we are hearing from a keynote speech from the voice of the academics. Ladies and gentlemen, it's my absolute pleasure to welcome someone without whom today's event would simply not happen. Professor Ed Hovy is the Executive Director of Melbourne Connect. And from the very beginning of this program, he has been very supportive to us, from helping us to secure this wonderful venue we are standing in today, to spreading the words, promoting our event, and now standing here to share some of his insights. His guidance and generosity have had made NextGen AI events into a reality. So please join me in welcoming Professor Eduard Hovy, please. Thank you.
Hello, thank you for the nice welcome. It's a great pleasure to be here and to see so many people. There's more spaces up here if you want to come and sit. There's lots more seats up there. So, I'm both. Half of me is the Executive Director of Melbourne Connect, and the other half of me is a computer science professor. And all my life, I've been working on AI, on language models. I was working with since 2013 when they first came into NLP. My area is NLP. So my heart is there, and that's what I'd like to talk about today. But if you give me permission, I'd just like to do one little slide on what is Melbourne Connect. Why are we here? What is this place? If you think about a university, they started in the year like 1100 in Bologna in Italy, the first formal university. Students go, they learn the courses, they get some kind of diploma. That was the beginning. And 400 or 500 years later, there was a group of people who were the professors who decided, I don't like teaching, I just want to do research. And they spun out this sort of almost like monasteries, little areas where they just do the research, and that became sort of the beginning of the research side of the university, where people sit and they just think about stuff. And those two functions are very different, right? The teaching function is courses and exams and stuff, and the research function is funding and IP licensing and all that kind of thing, right? That sort of research area. But over the years, since the Industrial Revolution, society has discovered, hey, look, there's a bunch of clever people there, and they can do things for me, and they can train my people. So society came and increasingly looked at universities and said, teach my people and answer my problems. Help, bring your research, bring your expertise. Melbourne Connect is one of these delivery places. There's about 140 places like that around the world that are sort of like this. This place cost $500 million to build. There's about 50, 55 companies or pieces of companies here. There's all of IT, Department of Computer Science, other things, lots of stuff, other people here, an entrepreneurial center and a training center, etc. So all of that, the function is to try to bring the two sides of the world together. And this event, this NextGen event, is exactly in the focus point of what we're trying to do here in Melbourne Connect. So welcome, and then I hope I can share some ideas about where AI is going next, because we're talking about next generation. So let's think about, for a minute, let's look, as you know, AI started in 1956, right? Or just around then. But lately, with ChatGPT and generative AI, that's the AI that can actually generate, not just sit there with a big knowledge base, it accelerated since November 2022 when ChatGPT 3.5 came out, and it has bloomed and just taken over the world. Now, if you look at this, you might say, well, where are things going? They go so quickly. Where do we end? What must we do as an academic, as a company, as a government? What's the shape of this thing? So what I think is happening is there are three major directions. Number one direction is making LLMs usable, just so that you can say, I have this thing and I want to be able to use it. What must I be able to do? Well, I have to build smaller LLMs because these big things, the world in which there's just like 2 big LLMs or 5 big LLMs, that would be a terrible world. Today, we live in a world where there's one Google and maybe 3 or 4 other search engines, and that's your choice. That's a disaster, thank you. That's a disaster. I predict, I think, what's going to happen within 5 to 6 years, we're going to have hundreds of small LLMs. If you think of the history of computer science, in the beginning there was like 5, 6 big computers and the whole world went to them. Today, everybody has a laptop and a tablet. You have 2 futures. You can have one or a few big machines everybody's using and then they own you, right? Or you can have thousands of little machines and you can do your own. I think, given what I'm seeing, that LLM land is going into the second one, where there's going to be lots of them, smaller ones, that every company, every university will have their own, every hospital and so on, down to a certain size. There's a question of how you build it, how you train it, what kind of data you bring in, what's the platform you start with, etc. So that's all part of making these things usable. You have to figure out how to do prompts, and I want to tell you a little bit about how you actually use this thing to make the prompts useful, as opposed to just writing 2, 3 sentences. You don't know if it's a good prompt or a bad prompt. You don't know how to evaluate that stuff. You have to worry about your energy cost, your water cost, etc. So I'll touch on these points a little bit. The second major direction is, okay, let's say you got your LLM and is running for you. Now it's actually got to make money for you. It's got to be useful. You want to make it actually do something. How do you do that? How do you take an LLM and tune it to your domain, right? How do you make it actually respond to your circumstances as they change? How do you not steal other people's stuff and land into lawsuits because you're stealing their IP, etc., right? How do you do all that kind of stuff? There's a whole bunch of interesting work, integrating multiple media, integrating time and change over time, that is in this space. The third space, if you think about it, is we still don't really know how they work. There's no expert in the whole world who could actually sit and say, you give me an LLM, you tell me what you want to change, I'll do brain surgery and the thing will be different in the future. Nobody I know, because I have projects working on exactly this point, not even Anthropic, which is where all the brains is today, not even Anthropic can tell you exactly how their LLM reaches the results it does, how the inference goes. That's a big problem for us, because it means LLMs cannot explain adequately what they're doing. And when they make a mistake, and as you know, they hallucinate all over the show, you can't get a good explanation that you can go in front of a judge and say, your LLM caused my child to die. Why? I don't know, sir. It's the training data. It doesn't work, right? You want something that, like a human, can explain why they reasoned, and then maybe the judge will be lenient. We have to figure out how these things work, how to fix them, how to make them work better, right? That's a big part of the research work. So I would like to touch on each of these 3 points and give you small examples of each of these 3, what's happening in the research world today, and how that's going to be transitioning out into the real world through startups, through companies like this, exactly in the form of hackathons. You guys, you hackathon guys, are the guys who carry these ideas and work with them and make them real. This is one of the most important things that we can do today, and I want to congratulate and thank the hackathon organizers, you guys here, for actually making it happen. You're the guys who make the focus happen that the companies can pick up. Okay, let's look at making AI usable. It started off as a gimmick. Sure, yeah, you can do all these little things. And there was the old chatbot named Eliza, you might have heard of it, in 1977 from Weizenbaum, from MIT, all the way through to ChatGPT. And today, this is the picture. Look at that thing, right? There, where the big arrow, the bottom arrow is, there, that little box F, that's the LLM. And underneath of it, you have all the chips and NVIDIA's coming in, and all the servers and all the big stuff, and AWS and all these platforms. They don't build anything, they just build the environment. On top of them, you have all these instruction applications and all these sort of frameworks that you put in, and then all the verticals on top of that there with the second arrow is that just says, oh, you want to do biomedicine? Oh, you want to do this? Oh, you want to do that? All the companies come in and do that top thing. Look how this infrastructure is growing. When do you think it started growing? More or less 3 years ago. This is amazing, this growth, right? But you have to understand that this stuff doesn't just happen for nothing. There's money inside. So if you can actually make box F better, and you can actually program it better with your prompt, or you can actually make it explain what it's doing better, you can actually have an effect on through the whole thing, right? So you've got to figure out where you fit, how you actually best fit in this ecosystem, and how you actually make things work for the benefit for everybody. Now, people say, well, AI is using all this energy, and we just had a talk in the Melbourne AI at Melbourne colloquium about 2 hours ago. John Whittle, the chief of Data 61 from CSIRO, he had some graphs where he said, oh, it's using all this energy. I actually think that's wrong. I've done some of my own analysis of this and studies, and if you look at this kind of curve, which is what you get from the Global Innovation Index, the publication from the whole global study from 2024, last year, the speed of chips and compute is going up a lot. The power usage is staying relatively constant for that speed, and the efficiency is therefore going up a little. If you look at the individual costs of things, in March 23, to run GPT cost about $50 US dollars per million tokens. Today, August, last month, it cost about 14 cents US cents per million tokens. That's 2 orders of magnitude difference. There's no reason to believe it's going to stop there. Things are getting cheaper to run, partly because the chips are getting faster, partly because people are better at optimizing what they're doing and not making so many mistakes and things like that. There's a whole bunch of reasons, but it does mean that the cost of running your tokens through the machine is less. 2 orders of magnitude in 3 years, 2 years. That's a lot, right? If you look at the marginal energy cost for one standard prompt of an LLM, it's about 0.0003 kilowatt hours. That's the same as using about 10 seconds of a download or streaming Netflix, or as one Google search was in 2008. That's not a hell of a lot of energy. Now, there's lots of people in the world using all this. Yeah, that's big energy from the whole footprint, but there's lots of people doing a lot of things in the world. This marginal, for the effect you get, I would argue, is actually quite cheap, and it's getting cheaper. People say the water usage is terrible. Well, the water use, according to this study, and you can see all the URLs up there, which is where the studies come from, for one standard prompt is from a few drops to a small thing of water to cool down the GPUs and so on. And that's also getting cheaper as the chips are getting more efficient. So I don't believe, I make a prediction here, that in 5 years' time, energy usage and water usage is going to be a big deal for LLMs. So when people say, don't do it because blah, 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 I think that's a mistake. Okay? That's just, you can quote me, right? So that's just one thing. If you look at performance versus cost, on the x-axis, you have the cost per million tokens on a log scale, right? And on the y-axis, you have performance. How good are these things? And how do you measure performance? Well, they have this here's one of many tests, GPQA. It's very hard multiple choice problems. And a non-expert, if you have a PhD, non-expert, you get about 34% correct on this test. If you have a PhD, you're up there in the sort of yellow range. Look at all the lines. Look how these machines get better and better and better. Many of them are doing better than a PhD is doing today, right? And look at the cost per million tokens. We're in the cost of $1 per million tokens, $5 per million tokens, right? For a million tokens, a lot of tokens. So it's getting cheaper and cheaper and getting better and better. That curve is not going away. That's why I think we are going to have a lot more small LLMs tuned just to your area. I don't care about chemistry. I don't care about astrophysics. I don't care about going to the moon or astrology. I just care about my own particular whatever it is. So give me the base model, like QN, some cheap model, and let me train my own thing on top of that, and I put him there in my basement, right? I run it on an H100 or an H200 maybe, right? Which costs me what? $10,000, $12,000 Australian? It's not impossible anymore. I need to know how to download and install the thing. All the students today, all my students are downloading their own versions of QN today by themselves on their machines, right? It's not impossible to run and train your own LLM. So don't go and buy Copilot, and don't go and talk to Anthropic and pay through the nose. Just wait and make your own, okay? For this sort of thing, for performance and environment, things are getting better fast, rapidly. That's the end of section 1. Is okay? You're with me? Yes? All right? Let's go section 2. How do we make this machine useful? Okay, so we got one in the basement, now what? Now the most useful application, if you look at the statistics so far, is on coding. These machines, because instead of having all of English, which has a vocabulary of about 300,000 words if you count names and things too. So in your head, you know about 120,000 words if you're a native English speaker. If you speak 2 languages, you know a little bit more. So let's say we put 300,000 words in the vocabulary, and we look at all the different ways you can say things. That's what an LLM is trained to do. That's why it takes 4 or 5 years to train an LLM big. But if you look at software, you got 300 words of Python, right? 3 orders of magnitude less, or 4 orders of magnitude less. And how many constructs are there in Python? 50? It's a simple syntax, a simple lexicon. You can train an LLM even with much less training data to speak perfect Python. And thank God, but in the Python, in the code you download from Hugging Face and everywhere, there's English because the authors write comments for you. So you can actually get the English comment associated with the Python structure. So you can begin to say, oh, okay, if I type my prompt in English, I can pull out my little pieces of Python code and put them together in code. That's how coding works. Vibe coding in Python or something else. Of course, it's not 100% correct. Nobody guarantees correctness. That's why you still need the programmer. That's why we will not be out of a job, whatever people say. You still have to fix the mistakes and the hallucination. But this is what's busy happening in the coding world. ANZ, they invited me 2 years ago. They have a group of about 13 people who check for cybersecurity break-ins. They get about 11 or 12 attacks every week. People trying to do fake attacks, fake password and things like this. They have these people who sit and check month by month, how do we fix the problems that sneak through? They started using ChatGPT's codex 2 years ago already, and they sped up their operation by about 13 to 14%, or maybe a little bit more, like 15 to 16%. Because they just give the problem to the machine, it writes the first draft of the code, they fix it, they check it, and they just go faster. They can handle more. This is what Anthropic, coding is what Anthropic puts its money in. Sam Altman, bless his heart, I don't like OpenAI, I don't like Sam Altman. They have no way of monetizing their business. It's like the early days of Google. They don't know how to make money. They charge you, what, 50 cents and $50 or whatever a month. They don't make the money. Right? Sam Altman doesn't know how to make money. All the brains left him because they can't stand the man. They all went to Anthropic. Anthropic has brains, and they have a good sense. They know how to monetize their thing. They're doing code. Anthropic is focusing on code. The fact that you can run Claude is sort of an accident. Yeah, they're being nice to you, right? This new big company, Thinking Machines, where she's got the CEO there has the biggest investment that's ever happened in the world. They're not saying what they're doing. They say, oh, we will do responsible, blah, blah, blah. You say, what exactly is your responsible thing? Zip, nothing, no? My prediction, my belief is they're going to try to put an LLM in every cell phone so that you will have your private mini LLM, not in your phone, on the cloud somewhere, that it'll know your photos, it'll know your phone number, it'll know your bank account, it'll know what holidays you've had, it'll know all about you, and you'll speak to this thing and it'll help you plan and run your life. And they'll put all the ethics and all the nice and all the responsible stuff in there and all the privacy. That's what I think they're doing, because there is the big scale. If I were doing an LLM company today, that's what I would do. And I would go big for the whole world, like Jeff Bezos did for sales. He said, the whole world, let's do Amazon for everything for the whole world. And look where he is today. That's what I think they're busy doing. So we'll see. So if you look at Claude, and you look at how Claude supports your coding, Claude Code, right, is actually a really nice package you can use today. You can put it on a terminal, you can do all kinds of things. I don't have time to go through all of this stuff, but Claude Code is a very easy environment to go upload and just write your code, and it'll help you vibe code, right? Help you actually make the code that you want to do. This leads us now to the different ways that coding is evolving. In the old days, that is 5 years ago, you learned to program. You learned Python, you learned Java, you learned in the old days COBOL, Fortran. In today's world, you speak prompt. You write prompts, right? You don't have to learn, you have to learn. I'll show you how you write proper prompts in a second, right? What's happening and what I'm seeing and what my postdoc is doing, what everybody's doing is you write 2 modes. When you want to write something that is structured, deterministic, careful, you write Python. You write your Python program. When you want to write something that is related to English or images and sort of vibe-ish and stuff, you jump into prompt space. So you do your prompt thing, the machine gives you back the results, you suck it into your Python side, you check it up, you sometimes jump out, and you do two modes of coding. You have a bimodal coding environment, which is part English, quasi-English prompt, and part traditional programming language. Now say, well, what's the environment? Well, here's an environment. LangGraph, for instance, gives you that environment. There's other ones where you have a nice short-term storage space, you have the RAG store, you have all this, you can speak two languages in there. I think that's what's going to happen to make programming easier for us. At some point you say, I have to do structured stuff, I stay Python. I have to do unstructured stuff, I go prompt. I have to marry them together, I do this one and this one, because all my applications are going to be multimedia and all this stuff. I live in this world. How hard is that? We're busy evolving that. That started maybe a year and a half ago, 18 months ago. I think that's going to be big business now. That's what I'm teaching my students now in some of the courses we have. Now let's look at prompts. In the old days, that is to say 5, 6 years, 10 years ago, you used to spend a lot of time on training and fine-tuning, and you do a little bit of prompting in the bottom. Look at the red line. Prompting is becoming more and more popular, where fine-tuning, do you spend a lot of time fine-tuning your engine and doing it? No, you don't, it's too expensive. You just prompt it better and you get the same result. We don't know today how to make a good prompt. We don't know how to fix our prompt. That's terrible. It may be that you don't have to fine-tune. It's all in there. You just have to prompt it correctly. How do you know? That's the question, right? So we're moving from prompt engineering to a new paradigm I think you can call prompt programming, where you're living in a quasi-non-deterministic world with a quasi-English programming language called prompt English, right? And it's not just prompt engineering. There's rules. I'll show you in the next slide, right? And you can actually then do all kinds of extra things in this prompt space, right? So prompt tuning becomes a big deal. Can you automatically improve your prompts? Can you put a prompt in the machine and say, make me a better prompt? I'm not a prompt expert. Who knows what you want, dear machine? Can you actually do it? So there's all kinds of techniques for doing this there, but the best one is something you can think of as prompt, prompt evolution. Here's a technique that people have started developing now, where you take a starter prompt and it evolves to a better prompt. How can you do that? How can you make a prompt automatically get better? 2 steps. Number 1, you need the mutator. You give your prompt to the LLM, same LLM. You say, hey, look, here's my prompt. Change that prompt, make it a better prompt. Keep the semantics the same, but just ask for more examples, do something, write whatever you want. And you say, give me 5 variations back. So this machine goes and it gives you, this is my input prompt, here's 5, 6, 20 answers, as many as I get. I'll show you an example in a second. Now you look at that result and you say, well, what's the better? I don't know how to judge a prompt. Let me take each of these variation prompts and throw them through the machine and see what comes back. So now I have a prompt and the response, number 1. The prompt and the response, number 2, number 3, number 4. I can look at this, the evaluator, me or my programmer or a machine, if I can evaluate, and I can say, that's a good one. Oh, that got better. This is not a good one. Junk, throw it away. Junk, good one. I keep the good ones. I go back to the mutator. I say, here's a better prompt. Please mutate that some more. And give me another 5 variations. Here's another good one. So now I've got 10 new variations. I run them through. I get new answers. I judge them again. I mutate. I evaluate. I mutate. I evaluate. I keep going up until my answers gets kind of constant. How hard is that? Right? You didn't think of that before, but think of this. You can do this afternoon. You get to a very good space where you can improve your prompt. There's some really nice results in this whole technique there. Okay? Can you evaluate the goodness of a prompt? Well, it would be nice if you could automate that. So here are some criteria. A short prompt is better than a long one. An accurate answer is better than a non-accurate one. A complete answer is better than a partial answer, etc. Many of these criteria have been studied in natural language processing in different fields: machine translation, information retrieval, language generation, dialogue processing. It's not impossible. I have not seen much work on this in the academic side, but this is coming. This is coming. 3, 4, 5 years from now, we're going to have a whole lot of papers on how you automatically evaluate prompts or prompt response pairs. So you'll have an evaluator that you can run that's automatic. That's great news, right? So now you have a machine, your own machine, and you can put the prompts in there, and they will run for you. It'll get better, and they'll run. There. What is this? Prompt tuning. Do we still have time? I still have a few more slides. Is it okay, right? So prompt tuning. How can you, we've talked about this. Oh, I'm going backward. Oh, that's my problem. I knew there was something wrong here. So here's AWS. Okay, this is their prompt evaluation package. They give you something. If you read it, it's all good, true things, but they don't tell you how to do it. It's typical AWS. Until you pay the money, they're not going to tell you. So don't do AWS, just think, or come to us here. We'll help you. Okay. Now here's prompt obedience. And this is the work of Yilin Gang, who's sitting there. Yilin, your hand, please, right? Does this machine listen to your prompt? It turns out that when you write an LLM, you put on the top, a system prompt that says, be careful, do not lie, do not swear, do not tell untruth. It's about a page long. I can send you a real one, right? And that thing is stuck on front of every prompt that you give in because it's reminding the machine, don't lie, don't swear, don't be biased, blah, blah, blah. Do these machines actually listen, said Yilin, to these prompts? Let me do a clever experiment. This is a genius experiment. What he did is he takes a prompt and he puts contradictory information in the prompt. So he says at the top of the prompt, I want my answer in Spanish. And then he gives the question. And at the bottom of the prompt he says, answer me in English. Now, what would you do as a human? You'd say, come on, do you want Spanish or English? No, 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 no. These machines, they happily, some take Spanish, some take English, some do a mixture. It's a complete disaster. Then he says, I want a short one, 300 words maximum. He gives a question, give me a long answer, at least 500 words. Do you think they'd learn? No, 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 no. Some go first, some go the last thing, some mix them. It's a complete mess. Every engine has its own behavior. The only engine that actually listens and discovers there's a problem is Grok, Elon Musk's Grok. Why? His theory is because it's doing the answer, it's getting the result, and then it's looking again on the second pass to say, here's the question, is the answer, is it good? And it says, well, there's a mismatch. You want Spanish, but you give me English. Something's wrong, right? Only when you do a two-stage thing can you actually get the result. So Yilin is looking at me kind of like, I'm simplifying your story, but this is basically, you can read the paper on arXiv. It's a very nice paper. The story is, these engines do not listen to your prompts, so you cannot trust that the engine is doing what you tell it to do. The best you can do is write a prompt, evolve your prompt, and then check. Never trust. Never trust. It's not the case that these machines are going to put us all out of business, that we won't have anything to do anymore. The society wants correctness. The only way we can guarantee correctness until we know how to do brain surgery on these machines is actually to have a human check, right? So I suspect what's going to happen is we're going to have a lot of acceleration where the LLMs are going to do a lot of the simple first draft work, but then all the work that people are doing is going to come at the end and say, let me check this bloody machine, let me make sure it's correct. If it's not correct, I need to change something. I think that's where the focus is moving. So for code development and testing, things are getting better. Let's quickly go to the third part, making AI understandable. And that's a very interesting question now. There's a lot of work on trying to understand how the LLM thinks on the inside. Now, if I look at you and I say, how did you come to this conclusion? And I ask you or my 11-year-old daughter or something, you will tell me your intuitive feeling of how you came to the conclusion. If you ask an LLM, you told me this, why did you tell me this? It'll tell you a bunch of stuff. The question is that true? Is that actually how the LLM thought? Is it actually how you thought? It's what you think you thought, but is that the truth? How can I possibly prove that what you said or what it said is actually the truth of how it thought? How can I make my claim strong, right? It's an actually interesting scientific question. I can't just query you, because you can say anything. You can have a dream about how you thought, right? You might have been hypnotized to think you think a different way. What I would have to do is go into your brain and change your neurons. I would have to go into the LLM and change its wiring or its weightings so that I can make the effect that I want to make, right? If I can do that, and you tell me, this thing said this, I want you to say that, and I go in and I do my magic tricks, and now it says what you wanted, you would have to say, you know what to change. Especially if I don't change everything, I just change that one little thing. So I have a project now, actually a very interesting project with some students working on exactly this, and we have some nice results. So people have tried to do this. So Anthropic has a thing they call circuits, and there's a whole lot of literature about circuits, but it's not the same, it doesn't really work. There's a very nice example called the Golden Gate Bridge example that Anthropic made a year ago, where they just upweighted the Golden Gate Bridge. So anything you ask this LLM, Claude at that time, the upweighted one, it will answer Golden Gate Bridge. Where shall I go on a holiday? Go to San Francisco, because the Golden Gate Bridge is there. What job should I do? Become a painter, because you can paint the Golden Gate Bridge, right? It's upweighting Golden Gate Bridge into any answer it's generating out. We call that damage. I don't want to make everything polluted. I just want to make one little thing different. I want to remove one kind of bias. One of our experiments is to saying, how can we remove the bias on nurses? If you ask any LLM today, is the nurse a male or a female? It'll say female. If you ask any LLM today, show me a picture of a CEO, it'll give you a white male like me, right? That's bias. How do you change that bias? And how do you change the bias that when the nurse now becomes male, but if the nurse is pregnant, the nurse has to stay female? How do you do that? What neuron do you change? You show me the neuron to change to make that work. It's not that easy, right? So we have this procedure we've developed to try to do the surgery, to try to prove inside exactly what little thing you must touch, and a technique called steering vector, how you steer the reasoning from one place to another, how you force it to go somewhere else. This is really, really interesting work. And if that works, 4, 5, 6 years from now, we will probably be able to much more accurately pinpoint inside the neural network, where is the bias? Where is the thing I need to update because there's a new American president? Where is the thing I need to remove because it's just hateful or it's IP violation or something? We can't do that today. But if we can do that, we will say we begin to understand the LLM better. So if we could get that sort of capability, then for explanation and assurance, things will become better too. We're not there yet. I don't think it's going to happen fast. That's a difficult problem. But if you couple these three things together, we get smaller machines, cheaper to run, faster, not so much energy usage and water usage. We know how to program in bimodal with prompts and with traditional programming, and we know how to go between, and we know how to make our prompts better automatically. We know how to judge the goodness of a prompt, and we can actually do surgery on the inside of a neural network. Then we come to a very interesting world where there may be a little LLM for everybody. And you pay Telstra $50 a month and you got yours, right? And you don't like something, you do the right thing, it'll change it for you. Imagine that. That's, if you're an optimist, I think that's the path we're going. That's what I think is busy happening. So that's all. The conclusion is just what I said. Thank you very much.